Hey class, Mrs. Anderson here. Today's video is going to be go along with 2.1b, solving systems by substitution. So we've already solved systems by graphing, and we've talked about how we can have three types of solutions. Remember, a solution to a system is where the functions intersect, where they are equal. So it's an ordered pair where they intersect. And then sometimes they don't intersect, and so we have no solution, or they're the same line and then we have infinitely many solutions. But sometimes graphing doesn't always work, so this is a method to do it algebraically, and so it's substitution. And we'll see algebraically what happens when you have one solution, no solution, and many solutions as well. So first, to do substitution, I set it up horizontally, and it helps me keep myself organized. So I set it up by putting the first equation on the left side and then the second equation on the right here. And then in order to do substitution, you have to have one variable isolated, which means you want to either have y equals or you have x equals. If you have y equals, then you're going to substitute it or replace it for the y. If you have x equals, then you would replace it for the x. So here in example 1, we already have y equals, and we have y equals 2x. So I'm going to substitute that 2x in the second equation for y. So substitute means to replace. So I'm going to have 7x minus, and then replace the y with 2x equals 15. And then on the right, I'm going to continue to solve. Since I plugged in x, then now I'm going to solve for x. So this really is just 7x minus 2x. If I distribute that negative here, equals 15. Combine like terms, 5x equals 15. Inverse operations, divide by 5 on both sides, and I get x equals 3. Remember, the solution needs to be an ordered pair, though. I've only done the right side, so now you need to take this x and plug it back in over here for x and get 2 times 3, and so y equals 6. And then your final answer is going to be written as an ordered pair. Remember, ordered pairs are x comma y, and so this will be 3, 6, and that's your answer. So these two lines intersect in an ordered pair, 3, 6. That's where they are equal. That's the solution to this system of equations. Okay, let's look at example 2. So I like to set it up horizontally. So I put the first equation on the left, the second equation on the right, and I have y equals, so y is isolated. So I'm going to take what y equals and replace the y in this equation. So that'll be 3x minus, I want to keep my parentheses, then plug in for y, so negative 2x plus 8, and then that was 17. And now I'm going to finish solving. So I have x's to solve for. So I have 3x minus this parenthesis. That's like having 3x minus, and there's like a negative 1 here, coefficient. So you actually have to distribute that negative or distribute that negative 1 in here. So you would take 3x and then minus, so I mean, negative 1 times negative 2 is going to be plus 2x. And then negative 1 times negative 8 is going to be negative 8. So you have to distribute when you have a parenthesis that includes more than one thing. So this had a 2x plus 8, so I had to distribute the negative to both. Now I can continue and combine my like terms. 2x plus 3x is 5x, minus 8 equals 17. Continue solving using inverse operations. So minus 8, to move that to the other side, I add 8. I get 5x equals 25. Then that's 5 times x, so divide by 5 on both sides, and we get x equals 5. But you're not done yet. Take that x equals 5 and plug it back into the equation on the right side. So it'd be negative 2, plugging in, substituting 5 in for x, be negative 2 times 5 plus 8, be negative 10 plus 8, which equals -2. So then we have 5, -2. 5, -2. And that's our solution. We want to write it as an ordered pair. Make sure you have parentheses. Okay, notice that these equations are both equal to y. So if they both equal y, then you can set the equations equal to each other. So you can set equations equal. Essentially, you're doing the same thing. You have y equals 2x plus 1 and y equals x plus 3. You're taking this equation and substituting it in for this y. So you're setting the equations equal. 2x plus 1 equals x plus 3. Then solve for x. Since I have variables on both sides, I will need to move one of the x's to the other side. I'm going to start by subtracting this x. So you move variables to one side. 2x minus x is really like 2x minus 1x, which is x. I have plus 1. Over here, I still have a 3. Since I moved my variables to the left, I'll need to move my constants, my numbers, to the right. The opposite of plus 1 is minus 1. So that would give me just x on the left, and 3 minus 1 is 2. So x equals 2. So now you can plug x equals 2 into either equation up here, and you're going to get 5 no matter what. If x equals 2, y equals 5. But I'm just going to plug it back into this equation on the left. So y equals 2, and x is 2 plus 1. So 4 plus 1, y equals 5. So my final answer with x is 2 and y is 5. So x, y. All right. Moving right along here, let's go to example 4. Start by getting it set up. And then I have 6x plus 2y equals 1. So I have y solved, and sometimes you do have to do a little work to solve for your variable. To make these examples a little easier, I have it y equals. And so I'm going to plug that in here for the other y. So substituting in for that y. So then I will have 6x plus 2 parentheses, plugging in the negative 3x plus 5, and then that was all equal to 1. Once you have that, you'll need to distribute. The 6x stays the same, plus 2 times negative 3x will be negative 6x. 2 times 5 is plus 10 equals 1. And then now you can combine like terms. Well, here I have a 6x and a negative 6x. That's really going to be 0x plus 10 equals 1. Well, 0 times x is just 0, so 10 equals 1. Now 10 equals 1 is not true. 10 does not equal 1. So this is actually a system when this happens, when the x's cancel and then the constants are not equal, it's no solution. No solutions. No solution. If you would think back on this equation, 6x plus 2y equals 1. If you were to solve this one for y, so 2y equals negative 6x plus 1, you would see that you get y equals negative 3x plus a half. So your slopes are both negative 3 for those. So it's actually parallel lines. So that's why they do not intersect. So they have no solution. And then algebraically, we get down to something like this. So your variables cancel, and you get like A that does not equal B, like two numbers that do not equal each other. Cancel. Okay. Now this one, as set up, it would be, it doesn't quite work out the way I wanted it to. I think this 6 is supposed to be a 9 in the second equation there. So Amy is walking a straight path that can be represented by the equations y equals 2x plus 3. At the same time, Kendra's walking a straight path that has the equation 3y equals 6x plus 9. What is the solution? So if I take Amy's walking path of 2x plus 3, and I take Kendra's walking path of 3y equals 6x plus 9 because I changed it, I can substitute in for y, because that's what the variable I've isolated, and you're going to get 3 times 2x plus 3 equals 6x plus 9. Distributing the 3, I'm going to get 6x plus 9 equals 6x plus 9. And so right here, 6x plus 9 equals 6x plus 9. Hopefully you can see that these are the same line. They have the same slope, same y-intercept, so it's going to be many solutions. So if you can identify it there, or you know, if you want to continue solving this, you could say, okay, I'm going to subtract 6x on both sides. Then I'm going to get down to 9 equals 9. If you get to 9 equals 9, that is true. So many solutions. Even if you went a step farther and subtracted 9 on both sides, you get 0 equals 0. Still true, many solutions. So the difference between no solution is that I had like 10 that doesn't equal 1. And many solutions is I had 2 things that were the same. So it'd be like A equals A, and that's true, so that's many solutions. So the variables still cancel, you're left with constants, but they're the same number. So that's the difference there. Okay, so that wraps it up for notes. So you can stop here. Sometimes though we do have to plug in for x instead of y. So I just wanted to say, like, what if I had x plus 2y equals 6, and then I had 3x minus 4y equals 2. So I would want to isolate this x here by solving first for x, and so I get negative 2y plus 6. And then it works the same way. You just have x equals, so I plug in this negative 2y plus 6 for x instead. So then you just replace the x with negative 2y plus 6. And then you would continue solving it just like you've done in the past, but you would solve, so distribute, you would end up solving for y, and I don't think this is probably going to work out very nicely since I just made it up. Negative 6 and negative 4 is negative 10y. That's going to be negative 16, so I end up with a positive 1.6. And then you would have to take that y and you'd plug it back in up here for x. And so negative 2 times 1.6 plus 6, that's going to be negative 2 times 1.6, 16 plus 16 is 32. So 3.2 plus 6, 3.2 plus 6. I'm really testing my mental math skills here. 2.8. And then when you write your ordered pair, you would still write it as 2.8 comma 1.6. So substitution does work. Still, when you have to isolate the x, then you plug in for x and still solve. And sometimes you get decimals because they don't always intersect at an exact point. Okay, that wraps it up then. Thanks for watching.